Hey there, some help with section 4.6. So we're going to talk about using random assignment, why we do that, and why we keep other variables the same when we do experiments. So what we have here is an experiment that's talking about TV and how it affects people's eating habits. So a recent study said that the type of program that's being watched does influence how much people eat. It said 94 college students were randomly assigned one of three treatments. So watching TV, 20 minutes of a Hollywood action movie, watching the same movie but with no sound, that'd be fun, and then watching 20 minutes of an interview program. And then they were given snacks during that, allowed to eat as much as they wanted. And then it says the subjects who watched the movie with sound ate 65% more calories than the subjects who watched the interview show. And then the subjects that watched the silent movie, same version of the movie, ate 46 more calories than those who watched the interview show. So it looks like the interview show is almost kind of like the control group here, our baseline, and then the Hollywood movies are the experiment. So explain the purpose of the random assignment here. So the random assignment is, so when we have the group of 94 people that have already been sampled, so not the random sampling, but the random assignment. So we have those 94 people, and then randomly assigning them to one of the three treatments. What's the purpose of that? So the purpose of the random assignment, the purpose of randomly assigning them to which treatment they are participating in is to create roughly equivalent groups. At the start of the experiment. And then that way we can look at the groups at the end of the experiment and compare how they've changed at the start of the experiment. And this helps avoid confounding. So, these 94 people, they're not going to be the same size. They're not going to be the same amount of hunger that they came to with. This random assignment should help distribute those things throughout the different treatments. So that, let's just say that the people that chose to watch the action movie with sound just happen to be bigger, dude bros, and they just are hungry when they go in there and they watch the movie, the show, and then the people that are picking the interview, they're more your quiet, bookish types, and so they're going to eat less, right? And so those things are going to affect the results. Those are going to confound that. Was it just how hungry they were? That's what affected how much they ate? Was it just how big they were? Is that what affected the results here? If we can randomly distribute that through the different treatments, then we shouldn't have to worry about that. And avoid confounding. All of the treatments was the length of the show they watched. So that same context, researchers determined that people consume more calories watching shows that are more entertaining. Identify one variable that the researchers kept the same for all subjects during the experiment. Provide two reasons why it was important for them to do that. So one thing that was the same during all so the length of the clip or the length of just the amount of time, length of time they watch TV. Was kept the same for all the treatments, for all three treatments. why it was important to do that. So that if they just got to choose how much time they watched. If they sat there for 60 minutes watched, that we expect them to consume more calories. And so that is it the length of time that they sat there that determined the calories they consumed, or is it the program they're watching? Right, that's confounding. So if the individuals got to choose how much time to spend watching TV, we wouldn't know if it was the length of time or the type of programming that affected their calorie intake. That would also, them being allowed to pick how much TV they would watch would also increase or make the variability of the amount of calories they consumed, the response variable. And make it harder to tell. If the type of program made a difference. So the idea here with this idea it's harder to tell if the type of program makes a difference. As we just look at, if we had some dot plot of how many calories were consumed from 0 to 500, and then all the people that were in the watching the action movie with sound, their data is we got 20 data points up here, and then obviously people that are watching action movie with no sound, their data points maybe are in here, they consume less calories. They're 20 dots, and then all the people that watched the plain old movie with the interview show, their dots are here, and so we see that the clusters makes it pretty clear that okay, these people definitely consume more calories than these people. These people consume more calories than this people, but not as many as this. Whereas if they got to pick how much TV they watched, and we kind of thought that same thing. Well, what if the people that watched the movie with sound, got to pick how much TV they watch, and so some of them, maybe the data starts looking like this, and then the people that, because some people didn't watch much TV, they left, they only ate a little bit, and then there's people that watched a whole bunch and ate more, and then kind of do the same thing. We get down to the interview one, and we end up with data, here for the interview one, and so as the dots kind of get crossed over and overlap, we see less of a difference. So, still maybe overall the people here, and the yellow did more, consumed more, but with all the overlapping, it's not as clear. So as the variability increases, as the dots spread out, it makes the differences between the different treatments less clear. So we want to try to reduce that variability. All right, I'll see you guys later. Hope you were able to figure everything out.